listening to Interchain FM, the Cosmos radio station. If you are seeking alpha in the cosmos, look no further. I'm your host, Chjango and Chain. I'm here with Mayur, the founder of Vistara. It's a very new AI/EPIN project. Full disclosure, I am an investor in Vistara. So welcome to the show, Mayur.
No, glad to be here.
What is Vistara?
Vistara is the future of decentralized hardware resource allocation. What that means is we want to pull together global hardware resources that could be compute, storage, networking, and being able to allocate them more efficiently so they are not underutilized or out of capacity, right? So being able to give access to that hardware physical layer, making it programmable, will allow developers to build distributed systems of scale that are possible in Web 2, but not in Web 3 just yet. The reason being, it's like Web 2 is really good at sharing resources in terms of like cloud providers, right? So there may be like 5 cloud providers, top 5 providers that every node, every network is running on it. We want to decentralize that and use virtualization technology to really enable the Web 2 like resource sharing so that I should be able to deploy my video streaming network, for example, on a decentralized hardware.
So just to help people understand what the problem space is in layman's terms, the reason why Web 2 has been able to scale as compared to Web 3 are, XYZ reasons. We'll get into that. But right now, from a layman's perspective, observing like what's been going on at the infrastructure level, for a lot of these Web3 projects is that there's so many single points of failure. We've regressed from having actually decentralized features because if you're running on EVM, it's too bloated and you basically need to trust 1 or 2 providers, Alchemy and Infura, like the main ones, right? And so you're no longer, or if you're looking at any proof of stake chain, a significant percentage of those validators are actually running on cloud and not actually bare metal. It may be centralized in certain regions, and so it's not ideal when it comes to critical network infrastructure.
In layman's terms, really is that even the most of Ethereum validators run on the cloud, and new networks, even new L2s or rollups would really want to, it's not valuable if they just deploy it on the cloud, right? Like we are able to decentralize the DeFi layer in the sense that is the only decentralized version and everything else is just still running on cloud or some sort of centralized services. And in centralized services, it works well, but you obviously have like censorship issues that a cloud provider can say like you're not able to run or mine something on this network. So we believe in like open hardware access that can enable a lot of different types of applications in Web 3 similar to the scale of Web 2.
Can you help people understand why Web 2 is able to scale? And we know Web 2 is able to scale to web scale because it's centralized. But then how do you bring those properties to Web 3 where it's ostensibly decentralized and scale?
Right. So Web 2 has been using a lot of virtualization technologies to make optimal use of the hardware resources. So for example, if I just even want to train an AI model, I could just go to AWS and say, create a virtual machine and deploy it. But
and the thing about AWS is that those servers are all concentrated and owned by
Amazon, yeah.
And that's why they're able to quickly virtualize.
They're able to virtualize it. Virtualization concept in Web 3 is enabled at the way higher level of the network stack, but not at the physical hardware layer. If we wanted to deploy like any type of AI training model training software, like if it could go on a GPU or it could run on a CPU, but like if it doesn't need GPU, then there's no point deploying it on it because that is wasted resources. And it's not just about wasting those resources. It's more like not losing the opportunity to opportunity cost of actually running different networks.
When you say opportunity cost, are you suggesting that right now in the current Web3 DePIN vertical that the hardware is actually either like it's like binary, completely underutilized or completely overutilized? And you're saying that there's no such orchestration layer that would optimize the utilization of this hardware?
There isn't, so that's what we're building, that orchestration and abstraction layer that is going to allow you to, as a hardware operator, to run even multiple networks on the single machine, and that's
Multiple networks meaning like multiple chains.
different chains on a single machine, and they will be secure in an isolated way so that they won't be able to interfere with each other. So they'll actually act like they're running on two separate hardware, but it's just on the same hardware and providing that much security.
In the Cosmos ecosystem, there's actually something similar. It's called a cache. So how is this similar to a cache or different in some sort of way?
So
a
Akash.
cache is like filling the same like use case, I suppose.
Yeah. So Akash is a great decentralized compute network. It offers compute through their data centers that run Kubernetes clusters. So Akash provides that, but you also need more than just compute. You need storage, you need bandwidth, you need I/O virtualization, even wireless virtualization at some point, which is not. So a lot of DP networks today just specialize in providing one resource. So like Akash provides compute, Filecoin provides storage, and Helium provides bandwidth through their networks. So, but people, as we were looking through, like people don't really want another DeFi swapping app, right? That you just swap one coin to another. People want more meaningful services like social media, content, AI, even streaming. And for that, you can't just offer one hardware resource as a service. You need to offer everything together, and not only providing access to that hardware, but also you have to you need to have the ability to morph that hardware into networking and storage and compute that is required for your particular application, and that is what Vistara is enabling through virtualization.
Where does Vistara source the hardware from?
We will start with like smaller data centers or people with the spare GPUs, for example, they wanted to rent out. Those are like, it could be just idle, and they would be pooled together so that
You mean like in the current state, a lot of this hardware is sitting idle or in storage somewhere, and you're saying that once Vistara is more widely utilized, that there's more incentive for people to run their idle hardware?
Yeah, so they're basically able to get maximum value out of your hardware, right? Mm-hmm. You don't want to just run one hardware and one network or one application on the hardware, and the rest of it is underutilized, not utilized at all. So you are just wasting those resources, but really important resources, hardware resources, not just like CPU or GPUs, but it could also go all the way to bandwidth, which is really scarce.
Yeah, there's something that I like what Greg, the founder of Akash, said, that you could, while you're charging your Tesla, the GPU in your Tesla could be potentially utilized to like provide compute for that distributed marketplace that Akash has. So yeah, very cool. In terms of Akash and Deepin, would they be able to use Vistara?
Yeah, so I think
or like BitTensor, other networks.
So Vistara, we can create this. We have a concept of Space Core, which is like a very small modular and atomic unit of the Vistara network. It's just a piece of software you write, similar to how you write microservices in Web 2, where it just does one thing really well, which in our case, it could be running full nodes, it could be running AI inferencing. So the example you gave about GPUs and a Tesla, so if they're not using it, those could be utilized by it, and they just need to run inference. So they don't need that much power resources.
These Deepin projects would be able to leverage Vistara as the underlying
infrastructure hardware provider. Yeah.
And from that perspective, would it be bare metal? How, or is it more bare metal access to hardware that otherwise would not have entered the marketplace?
Right.
To provide like a virtualized server for these other
any
cloud
nodes. Yeah.
Okay.
Yeah, so then we also would have, like, if you're running something on serverless computing on AWS Lambda, you should be able to just switch it to a more decentralized, more censorship resistant.
But why would they do that though? Is there lower cost?
There will be lower cost
Okay.
because you're removing all the intermediaries that a centralized person or entity to extract value, right?
Right.
We are not going to charge any tax on any deployments. So we believe that if we able to create something similar to like Cosmos SDK, right, which is allowing people to build different types of things, and now they're doing roll-ups with with the same SDK. So similar things, you build the space core, and then any network, any hardware provider in Vistara network is able to just run one command and operate a network instead of them having to go through like whole few pages of how to do docs and things like that.
Right. So that significantly lowers the educational barrier for running something like this yourself. And not only are you helping the network become like
more decentralized and scalable,
and scalable, but you're also lowering the barrier to entry of expertise to run these nodes.
Yeah, exactly.
Okay, so you said a keyword, space core. And so if someone wanted to use Vistara to run nodes for a new network, a new like proof of stake network, let's just say, what do they need to do? And you're saying it's for free. So, I mean, if a lot of the validators in a lot of these proof of stake ecosystems are currently, having to pay like a fixed OpEx cost, you're saying if it's free, then it reduces that to zero effectively?
Operation cost will be there, but like the cost reduction comes into like, because you're removing all the central point and single point of failure of centralized clouds, you are able to offer these resources a lot more cheaper than a traditional cloud would provide. And so as a developer,
as a validator who wants to use their GPUs to run these nodes,
so they would just run one command, and that is
the fixed cost just the electricity?
Yeah, it's just electricity at that point, like because you already have the resource, right? And that resource has X amount of capacity. You want to be able to utilize it as efficiently as possible. And that's what hypervisors and virtualization is going to enable. But we want to simplify a lot of that for developers. So for developers, in terms of like a new proof of stake network comes in, if they want 10,000 validators, right, or 10,000 light node operators, so a developer of that network could just build a standard space core through a configuration definition file, which is like, just to specify what hardware requirements you have and implement a simple interface in Golang. And then that allows you to, wrap your POS network into just like one command. Anyone can run it. And now one hardware operator could run 10 of these commands and 10 different networks.
All right, did you say Golang just because you're speaking in the context of Cosmos SDK, or is it actually language agnostic?
It will be language agnostic, but today we have our CLI written in Golang,
Oh, okay, all right.
Yeah, but it's also abstracted away so much that you only need to specify like the config and like where to get the binary from, and so it's simplified that streamlined that process as well.
That's really interesting. So this is kind of like what ICP wanted to do, but this actually would work.
Yeah, so ICP is very, very complicated. Plus, it's kind of like has a lot of bells and whistles, and we want to keep things as minimal as possible because that way we can serve diverse set of users and diverse set of applications, right? And diverse set of hardware requirements as well. So we cannot just, similar to ICP, we cannot have like an onboarding process of a data center onboarding and all of that. It would be permissionless. And everyone's ability, and there will be like a reputation system that everyone's ability to operate their nodes, and there will be like a marketplace there you can get.
So that's kind of similar. That's kind of like what we do for evaluating validators, but more in like structured manner,
right? Like programmatic manner. That's why programmable hardware is really important. That access is always existed in Web 2, and not it's just Web 3 just lags behind that, and that's what we're going to enable.
Now, let's say like the market of nodes gets for Vistara gets like significantly big. How do existing DPIN projects leverage this new powerful tool?
It could be existing networks, like legacy networks, could be modernized through using the latest hardware and latest software technology we are building. And that's just going to enable them to scale more and create more security, because that will be more decentralized hardware all around the world. So if a particular network or a particular app, like video streaming app, needs to be deployed for a live event of Boston Celtics game because it's an NBA final, and that's what I'm expecting that to happen in the Boston Celtics game. So like that live streaming, we need enough bandwidth and everyone to be able to serve that, and that's what auto scaling can provide. That can be done in Web 2, like Netflix does that,
Sure.
YouTube does that, but we want to be able to do it in more decentralized
For
way.
Web 3 to do that.
For Web 3 to be able to do that.
Obviously, if it's streaming, like none of that goes on chain, right? And if it's significant bandwidth, imagine me as a small user uploading the game through my GPU, let's say, in my home office. It's still like costing me some amount of money. What incentivizes someone to provide this service to the network?
Because you also want to be part of the network, and because you run a particular network, there are separate incentives from that. Each of those networks
right,
that
like
work with you.
presumably,
Presumably,
if I'm like a validator for that network and offering the service, then I'm basically like mining those tokens.
Yeah. Because we're using virtualization, you're able to run multiple networks. That gives you more opportunity to earn mining rewards, for example. It's kind of like restaking for hardware services, which is done through virtualization, that allows anyone to run these multiple networks on a single piece of hardware.
Okay, oh wow. Okay, so it's like, it's kind of like we're moving back to, I don't want to say proof of work because like the hardware are ASICs, but in this case it would be like proof of providing bandwidth to a network. In this particular use case.
Like this particular use case.
Or for like the AI use case, right? Like if I'm providing the hardware, so let's say I have like 5 GPUs. You're saying I could rehypothecate the same GPUs to run multiple networks. So it's like so they could be used for multiple different applications. AI being one of them.
It could be all AI, right?
Okay,
it could be all AI.
It could be like streaming.
Yeah.
It could be like storage or whatever. Running eigenlayer or whatever.
Yeah, you could deploy eigenlayer on top of it, like restaking service, right? So that's what is going to enable
hardware restaking as a service.
We could say that in a more open and permissionless way, which is important. And being able to share that means also, because the example you were providing was like if there is 5 GPUs. Let's say there is
so just because this marketplace of GPUs or even like data centers running bare metal is allowed, you're going to allow it to be standardized and rehypothecatable for running different networks.
Right.
Because of this, the different networks running on top of the Vistara's hardware layer, it could be visualized as a sort of like neural network of chains.
Yeah, it is possible, like network of chains, right? Like, and it's kind of similar to like just what you said. It's like a restaking of these hardware resources.
Yeah, it's so like that restaking, right?
But
because restaking in the EVM context is basically shared security of using the same validator set to like secure different rollups or AVSs in eigenlayer speak. But in this case, it would be you're restaking the same piece of hardware that you had, like the same GPU, to be able to reuse it
for different applications
in a parallel manner, running different chains.
Yeah, and it's not just limited to chains; it could be any type of application. But obviously, we will focus on the chains first as we try to get more decentralized. Yeah, that's the restaking, like a hardware layer, so that can make sure that it doesn't stay idle and keeps utilization high.
It harkens to how Bitcoin is actually good for the environment, because sources of energy that would otherwise be unharvested and idle are now being utilized to power the Bitcoin network. Water, thermal, all these other sources of energy that otherwise...
Even the energy grids, that type of stuff.
Right. It's kind of like the same incentivization mechanism for getting this idle pieces of hardware online, basically, and like making them productive.
Right, and that creates more opportunity for operators. If you have the resources sitting there, it's basically wasting those resources. And if we can share the hardware, it's like shared security, like a shared hardware liquidity. That's what we can enable, like even locations like India and some of them where you need specific type of resources like bandwidth in that way. So that's kind of like shared liquidity of hardware is how we think about it, and it's kind of going to enable a lot of different types of applications.
Or in DeFi speak, you're yield farming your hardware. So you can get your hardware to yield farm these different chains by virtue of Vistara's groundbreaking virtualization of your machine. So how does the virtualization work?
Virtualization is a concept that's been,
I'm not asking about it generally, more of like in the context of Vistara and how you're going to create this like standardized protocol for the hardware.
The way we're building this is what we call a hypercore. It's just an abstraction hypervisors, type 1 or type 2 hypervisors. They could go all the way up to...
I'm sorry, what are hypervisors?
Right, so hypervisor is just a virtual machine monitor that allows you to create or release virtual machines. And virtual machine is just a machine that acts like its own computer. So like you have one hardware that you can split that into 10 different hardware, and they will act like they're completely separate. That gets used in Web 2 everywhere. And so we're building this hypercore and one example of hypervisor, which is the Firecracker, which is type 1 hypervisor that is going to allow us to kind of provide serverless compute type of services, which is like, spin up a micro VM to serve an API request for GPU inferencing, GPU-based AI inferencing, right? And then serve that and shut it down or start it back up on demand. The similar techniques are being used in Web 2. It's just Web 3 is just not there yet, and that's what we're bringing.
In the Web 2 context, the model is very much client-server.
Right.
And so if you're doing serverless compute, now it's peer-to-peer?
So in Web 2 context, the serverless is just same thing. It's just on one data center, you just spin up the virtual machine in like 50 milliseconds and it shuts down. In our context, it would be in Web 3, it would be the request to create a resource would be sent on a peer-to-peer network, or it will be gossiped, and one of the nodes, one of the Vimana nodes, they will pick it up and they will have a hypercore abstraction service running, and that can read the hardware as code file that you create to deploy this space core. And that's how it is run on that particular machine.
Let's imagine there's a new roll-up or a new app chain that wants to utilize Vistara to bootstrap their network. How would they do that? And how do you maintain composability with the other GPUs that Vistara network is currently operating for other networks?
If I'm a developer trying to create a new space core, which is how Vistara runs any network, it's just that you specify your node requirements and hardware requirements in a TOML file, similar to like how Terraform and infrastructure as code in Web 2 does it. So Vistara interprets that and basically allocates those resources on given the requirements, and you implement a simple interface in Golang, like I was mentioning earlier, which just allows you to create a standard space core that can be used by anyone, and you can fork it and create different versions of it in case you don't like this implementation, right? Mm-hmm. So as a developer, if you want your network to grow, then you create this simple space core, and then everybody on Vistara running Vistara network will be able to just write one command and get a network up and running.
You mentioned Celestia earlier, because Vistara was pretty much supported Celestia node operation from day one. How many nodes are currently running?
Yeah, so since within a month, we were able to get like over 15,000 light node operators. Nice. Across like 45 countries. And
this is very important for DA.
Yeah, this is very important, right? Because light nodes scale, number of light nodes and the block size scales linearly. Mm-hmm. And it adds more security, more scalability. That's just one example, right? But it shows how easy it is to use Vimana, like software that we have, and anyone with or without DevOps and systems administrator expertise are able to just run this very easily. And if they can run one network, then similar way they can run 10 more networks. And now it's just using your hardware.
Are you suggesting that the people who are currently running light nodes on Vistara or Celestia could reuse the same hardware to run another network that they may want to support in the future?
Right. And they can run it right now. Like they can run like a Veil light node right now.
What sorts of applications do you think could be built on top of this network?
Yeah, so it doesn't have to be just eigenlayer, but like because you now have programmable access to hardware, you can build things that were not possible before. Things like video streaming network. It needs a lot of bandwidth that needs to be virtualized if there is an event, right? There could be examples like decentralized storage plus like a GitHub type, decentralized storage and GitHub together to make it more decentralized. There could be other applications like AI model training, but not just like GPU based. It could be CPU based also, like XGBoost type of models. So it's just things like what you want to, things that are possible in Web 2, you should be able to do that with the access to programmable hardware.
Okay, so are you suggesting that Vistara is the key that truly unlocks Uber on the blockchain?
You can create Uber on the blockchain,
or like Netflix on the blockchain. Decentralized streaming of the Super Bowl on the blockchain. Instead
of it all going through Netflix and on AWS
sure.
and AWS servers, right?
So and of course the data isn't actually being stored on chain. Rather, there's got to be this like on-demand streaming of like whatever, like bandwidth or offering something that enables the streaming, and then like some kind of like small compact thing, maybe like a proof or something that gets hashed, and then gets put on.
Yeah, there will be some sort of lightweight verification layer we will build on top, so just so we can just prove that things are being done honestly. We could potentially explore ZK stuff, but I think there's just it's not needed for these types of use cases. Right.
Going back to Celestia, what percentage of the network would you say is currently running Celestia using Vistara? Because
the Celestia light node network is not really that stable in the sense like people just start and stop, right? So start the light node, stop it whenever they feel like.
Yeah.
It's dynamic. So the 15,000 people, they need to continue running it, and we need to be able to monitor that. And I think that there is currently no way to do that. That's what we will potentially be building, or like we will be encouraging ecosystem of developers that want to build on it with Vistara. They could build that as a space core so that they can monitor things a little bit better. So it could be like observability space core that could be built, and that shows not just Celestia, some other networks too.
Do you imagine that over time, as more and more people migrate over from AWS to Vistara for basically the same services but much cheaper, that Vistara could feasibly be making up the majority of these networks that it runs?
Yeah, and the Space Core standard is going to make it easier for anyone to run those as well.
So the Space Core standard, by that you mean whatever chain and the specifications that are needed for like the underlying GPU or whatever.
Yes.
To like a Docker image.
It's like a containerized image, lightweight container. Docker is a little bit higher level of abstraction, and it's not as secure and not isolated. It shares the kernel space and so basically you run two programs and then you can access each other's data, which is not what we want. So that's why we go lower level, and that's where the type 1 hypervisor comes in.
That's great. What's coming down the roadmap for Vistara?
First version of Hypercore is going to come out, which is basically allowing you to deploy an API, for example, in more serverless computing way. And that would be like a start to get people excited or like learn about how to build more stuff or how to build Space Core on it. And that's how we're going to start onboarding like different types of networks and start creating this standard and promoting it as well.
From the standpoint that I'm coming from, because I see a lot of projects, this is kind of like a paradigm shift in moving the space back to the decentralized infrastructure that I was intended to be run on,
Right.
and not having these easy, convenient solutions like falling back to AWS and all these centralized providers.
Yeah, so just giving access to hardware, that's the paradigm shift we're enabling, and that means that you can just build whatever. Just like Celestia says, build whatever using whatever. That's you can actually do that.
With that, thank you for coming on the podcast.
Thank you for having me.